Introduction. Betelgeuse, the massive red supergiant star closest to Earth, has demonstrated a significant decrease in brightness in recent years, sparking a wide range of worldwide reactions. Some hypotheses suggest that this fading may indicate the approach of a supernova, catastrophic explosion that has people worried, scientists and the general public alike. The major Orion constellation star, Betelgeuse, has lost some of its previous brilliance, which has diminished, but it appears to be entering a reduced phase of activity. Currently, experts are considering Betelgeuse's future and whether an eventual detonation could have any impact on Earth. Orion, one of the most well-known constellations in the sky, is recognized for its two main stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the most luminous star in Orion. According to observations by NASA's Hubble Space Telescope and additional observatories, it was discovered that Betelgeuse was subjected to an extraordinary mass ejection event in 2019, an occurrence never recorded in any star of its nature. Despite coronal mass ejections, CMEs, being relatively common with our Sun, this particular outburst from Betelgeuse was unique and has generated intense fascination among astronomers. This huge explosion of mass expulsion was 400 billion times larger than the typical CME that stars similar to ours experience, briefly covering up some of its light, causing its peculiar dimming. Estimates of the distance between Earth and Betelgeuse vary, with some placing it as far as 724 light-years away. Calculating the distance to the red supergiant, Betelgeuse, and other giants is difficult because of their great distance and unusual characteristics. Betelgeuse, one of the most luminous stars visible from Earth, shines approximately 100,000 times the dazzling brightness of our Sun. This high luminosity comes at a price. Betelgeuse is exerting itself vigorously, rapidly consuming its fuel and speeding up its inevitable demise. The star will eventually exhaust its fuel supply, collapsing under its own gravity and increasing the risk of a violent supernova explosion that may, at some point, either leave behind a neutron star or a black hole. In light of current scientific understanding, does Betelgeuse pose a threat to Earth? In the event that the star explodes, explosion of a supernova could have devastating effects on Earth. Supernovae have the ability to release light with a brightness that rivals an entire galaxy. Even if Betelgeuse is comparatively far away, such an explosion would be difficult to ignore, since the last observed supernova in our galaxy was in 1604, and the most recent one in 1987 occurred in the Large Magellanic Cloud at a distance of 169,000 light-years. The destructive potential of a nearby supernova remains an intriguing yet concerning possibility. If such an event were to happen in our galaxy, it could have profound implications for Earth. Although spectacular, supernovae are much less powerful than gamma-ray bursts, which are on an entirely different scale. While supernovae have the potential to obliterate biospheres and blanket planets with lethal radiation, their ability to remove a planet's ozone layer is particularly troubling. A damaged or destroyed ozone layer exposes the world to dangerous ultraviolet light that could cause an extinction event. The initial burst of radiation from a supernova is threatening, but the more subtle threat is represented by cosmic rays that arrive thousands of years later, able to cause additional damage to the planet's surface and possibly prevent the recovery of life. Records from the past provide evidence of past supernova. For example, traces of iron-60, radioactive isotope formed during supernova explosions, have been observed in lunar regolith and Earth's oceans, implying that Earth might have been affected in the past by supernova a few million years ago. Despite this, astronomers have ruled out any imminent supernova dangers. However, they've discovered a second potential danger different kinds of supernova emit radiation that can travel great distances and cause harm to planets similar to Earth. As a star nears the final stages of its life, surrounded by a significant quantity of material, a specific type of supernova may occur. The shock wave from the initial explosion strikes the disk that surrounds it, causing the release of a large quantity of high-energy X-ray radiation. This radiation has the possibility of exhausting a planet's ozone layer by as much as 50%, which could cause an extinction event within a time span of 150 light-years. Thankfully, no such extra-emitting supernova are currently known to be sufficiently close to Earth to pose an immediate threat. These findings prompted astronomers to rethink the boundaries of the galactic habitable zone, the part of a galaxy where star formation is likely to support life. In the galaxy's outermost regions, star formation is too low to produce the required components for rocky planets, while the inner regions, where stars quickly emerge and disappear, are hazardous due to frequent supernova radiating radiation into the surroundings. According to research, the inner boundary of the galactic habitable zone may be farther from the galactic center than anticipated. How would a Betelgeuse supernova appear from Earth? While the biosphere on Earth would likely remain intact, the spectacle would certainly be impossible to miss. Goldberg and other astronomers claim that Betelgeuse's explosion would result in a brightness roughly equal to that of the full moon. Visible for several months, you would be able to see this brightness even in the middle of the day, and it would cast shadows at night. For several years thereafter, the supernova's ashes would remain visible to the naked eye. Despite Betelgeuse's supernova being an intriguing occurrence, it would not be without consequences. The global fascination with such a phenomenon cannot be denied, but the implications for Earth's future environment remain uncertain. Scientists continue to monitor this red supergiant. We can only wait and watch, hoping that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning appearance, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky after the sun, shining with such high intensity that it could easily outshine the moon. This would make the star visible to the naked eye during daylight hours, casting visible shadows in the darkest of nights. The sheer brilliance would captivate worldwide observers, despite its blinding light. It's important to note that the visible light emitted by a supernova represents only a small portion of the total amount of energy produced. The pressing concern is the high-energy radiation released, typically in the form of gamma rays and X-rays. These forms of radiation pose a grave threat and have the potential to strip Earth's ozone layer, shield of protection that impedes the passage of harmful ultraviolet light reaching the surface. In the absence of this layer, Earth's life would be exposed to dangerous levels of radiation, increasing the possibility of a massive extinction event. The explosion's aftermath would not end with the instantaneous surge of energy. Subatomic and cosmic rays, traveling nearly at the speed of light, would follow, continuing the devastation by dumping the equivalent of hundreds of tons of bombs on the planet thousands of years later. These particles have the ability to enter Earth's atmosphere, further degrading the ozone layer and potentially altering the course of life on the planet for millions of years. What happens next? Despite the fact that we haven't seen a supernova of this magnitude in our own galaxy for centuries, evidence of such happenings has been uncovered. Iron-60, a trace radioactive isotope created during supernova, has been discovered in samples of lunar soil and sediment layers, hinting that Earth may have been exposed to the fallout from a nearby star explosion within the past few million years. But there are no immediate dangers from Betelgeuse. Astronomers continue to keep a close watch on stars in the area, such as Betelgeuse. Researchers have also discovered another kind of supernova that could pose an even greater danger. In some instances, a star's final explosion can be surrounded by a massive disk of gas and dust. When the explosion's shockwave collides with this material, it produces an intense burst of X-ray radiation capable of traveling far. This X-ray emission can deplete a planet's ozone layer substantially, raising the possibility of a devastating extinction event. Supernova of this kind or not, however, is found close to Earth. If one were to occur within the next few hundred light-years, awareness of serious threat. Awareness of this additional danger has caused astronomers to revise their comprehension of the habitable region within our galaxy. Prior researchers believed that the galactic habitable zone was closer to the galactic center, but new findings suggest otherwise, emphasizing the need for continued observation and study of stars like Betelgeuse. The habitable region in the galaxy spreads out further away from the center of the galaxy. However, new evidence indicates that the inner parts, where stars are born and die quickly, might be much riskier than previously thought. The frequent supernova in these locations may bombard nearby planets with radiation, making them permanently uninhabitable. This has led researchers to believe that the galactic habitable zone may extend beyond what was originally thought. Looking to the future, what would a supernova like Betelgeuse look like from Earth? While the explosion itself would result in little to no immediate impact on Earth's biosphere, it would still be an amazing spectacle. According to researchers, the supernova would shine brightly, with a brightness equivalent to half of the moon. Visible for a few months. At its highest point, it would be so intense that it could be seen during the daytime, casting long shadows even in the dead of night. The supernova's remnants would continue to be apparent to the naked eye for several years, making it a truly unforgettable event in space and time. The spectacle of Betelgeuse's explosion would enthrall audiences all over the world, but its long-term effects on Earth remain a mystery. The supernova's radiation would still be a threat to the world, particularly with the possibility of the ozone layer being severely damaged. Although life on Earth may survive the actual event, the consequences of prolonged exposure to harmful radiation could alter the planet's ecosystems and may result in significant changes to the atmosphere for thousands or even millions of years. Over time, the possibility of a nearby supernova causing significant harm to Earth remains a subject of ongoing investigation and concern. The initial surge of energy from a supernova would most likely contain a combination of X-rays and gamma rays, which are capable of reducing the ozone layer that protects life on Earth from the harmful UV rays of the sun. The lack of this protective shield leaves the planet vulnerable to risky radiation that could have severe consequences for life, including possible extinctions that follow. Cosmic rays from the supernova's explosion, highly energetic particles, traveling at nearly the speed of light, would arrive and continue their destructive effects for hundreds to tens of thousands of years. Although the supernova's immediate blast might be devastating, it is the long-lasting repercussions of these cosmic rays that may prove to be even more destructive over time. They would keep disrupting Earth's environment, hindering the recovery of its ecosystems and potentially causing a prolonged period of instability for life. Iron-60, a radioactive isotope created by supernova, has been found in Earth's oceans and in samples of lunar soil. This discovery suggests that Earth has been exposed to the traces of a supernova explosion in the not-so-distant past, possibly within the last few million years. Despite astronomers not currently observing any supernova within a threatening distance, the detection of Iron-60 raises concerns about the potential hazards of a nearby star's explosion. These findings highlight the need to keep a close eye on nearby stars within our galaxy, specifically those in the final stages of their lives, such as Betelgeuse. In addition to the threat from conventional supernova, astronomers have discovered a potential danger from a particular kind of supernova. This occurs when a dying star is encircled by a large disk of gas and dust. As a result of the supernova explosion, a shock wave collides with the surrounding disk, producing a tremendous amount of X-ray radiation. This radiation has the ability to travel far distances and has the potential to substantially reduce the ozone layer of any planet with a radius comparable to or greater than Earth's. A planet subjected to such radiation might confront dire consequences, such as the beginning of a mass extinction. Fortunately, no stars showing this type of X-ray supernova are known to be located close to Earth. But the discovery has caused astronomers to reconsider the limits of the galactic habitable zone, area where it is most likely that life can exist. Previously, scientists assumed that the habitable zone of the galaxy grew farther from the center of the galaxy. As we proceed with our study of Betelgeuse and other stars nearing the end of their life cycles, astronomers focus on understanding the various ways in which a supernova could affect Earth's life. Even though the immediate danger posed by a distant star's supernova may not be catastrophic, the long-term consequences resulting from the radiation it releases are cause for concern. The excessive energy radiation generated by a supernova especially gamma and X-ray radiation, can have far-reaching consequences. Even if the star is far from Earth, it is this persistent radiation that can have lasting impacts on Earth's biosphere. 1. Aspect that has been gaining attention is the potential for future supernova to change the composition of Earth's atmosphere. Supernova can send shockwaves, radiation, and waves traveling through space at incredible speeds. If these waves reach Earth, they could cause widespread disruptions. Example, shock waves from a nearby explosion could potentially strip away much of Earth's atmosphere, disrupting the air we breathe and altering global weather patterns. Additionally, the released radiation could increase the number of mutations that occur in organisms, potentially leading to changes in evolution or the extinction of certain species. Another critical area of research involves the creation of nearby stars and the space around them. As stars like Betelgeuse near the end of their lives, they begin to shed material into space. This material, which may include heavier elements and gas dust, may play an important role in how a supernova develops. The interaction between the expanding material around a dying star and the supernova shockwave could influence the type and amount of radiation released. This interaction could, in turn, affect the extent of damage a supernova causes to any planet within range. Despite the absence of supernova, currently anticipated to pose an immediate threat to Earth, ongoing observations will continue to monitor the development of stars like Betelgeuse. As our capacity to detect and evaluate cosmic occurrences increases, so does our comprehension of how these stellar explosions might shape our planet's future. Scientists are hopeful that future discoveries will help mitigate the risks associated with supernova and enhance our capacity to anticipate how they will affect Earth's natural environment. By keeping an eye on the sky and studying the life cycles of stars, can prepare for the unexpected and ensure that we are better equipped to handle the challenges posed by these enormous planetary events.